Good morning, YouTube. It is December 15th, 2020, the year the year that shall live in infamy, right? Um, why won't you focus? Probably because I wasn't in front of it. That's better. All right. So, as things proceed apace with the climate, uh, it's becoming increasingly likely that we're not going to do anything to stop this freight train. And there's lots of reasons why. Um, it's going to be too painful. It's going to cause loss of life. It's going to cause loss of economic growth. It may cause the implosion of the economy as a whole. It will change the way people live their lives. It will change the way civilization proceeds, if at all. So there's lots of reasons why we're not going to do this. All right, it's pretty obvious we're not going to do this. I did a video yesterday or 2 days ago about how I've basically lost all hope. That not for myself personally, obviously, and not even for my neighbors, not this community anyway, rich white people. I just don't have any hope that we're going to take effective measures to stem this cataclysm. Let's just call it that, okay? Because people are now talking about removing carbon from our waste stream and then reusing it. So that's it. That's the end. That it's done. And if you don't understand that, watch my prior video on the topic. And maybe you still won't understand it. Maybe I'm not very good at explaining things. But in any case, I tried to explain why that's the end. That's the end. It's done. So if it's done, gears turning. All right. If it's done, and we need to start. We, meaning people like me who don't mind facing the truth. If we need to start dealing with that reality that our fight against global heating is over, then the next question that a thinking person might ask themselves is, so what comes after? What comes after? So there are clearly going to be near-term effects, like next year and the year after that, 10 years down the road, near term. There are going to be regional effects. Some places will be affected by heat. Some places will be affected by too much rain. Some people will be some areas, coastal areas, will be affected by sea level rise. So regional effects, different effects for different regions on short time scale, long time scales. But there's just the overall analysis of where this is all headed. Okay, irrespective of what happens in your neighborhood or what happens in your lifetime in the next 10 years, where is all this headed? So I'm a systems biologist. That's my claim. I'm claiming that. Those are special types of biologists, by the way. We're not interested in bugs and flowers and leaves and things like that. We take a bigger approach. It's not better. It's just different. Obviously, it's bigger. We look at whole systems. We look at how systems change over time, what causes them to change. We even take a long view, time spans. And there are a lot of evolutionary biologists that are technically systems biologists and vice versa, right? So, I'm a systems biologist, therefore, pretty much by requirement, I'm an evolutionary biologist because time matters and biology happens over time in a process we call evolution. So I just want to talk briefly, hopefully briefly, got other things to do, about what the implications are of all this for our planet, the big system, over time. Now, to understand that, you kind of have to understand where we came from. And there's not much talk about this. Some people will tell you, oh, well, we came from the dinosaurs. Not true. Okay, but there is some truth in that the planet that the dinosaurs inhabited 65 million years ago looked very different than the planet we inhabit today. And the difference is that the planet back then, when the dinosaurs and the reptiles dominated, was much warmer. I don't know what the difference was. It was maybe 10, 20 degrees C, 30, 40 degrees Fahrenheit. And it was that condition from one pole to the other. Okay. And it was largely forested. I mean, if you look at the large animals like the dinosaurs, they had a lot of food, right? You can't have animals that weigh 70 tons or whatever they weighed, 45 tons, herbivores that weigh 45 tons, and not have a lot of food around. Okay. So one of the things you probably could glean from just the fact that these gigantic animals existed and roamed the entire earth was that there was a lot of food everywhere there was land anyway. So we don't see that now, right? You don't see that. You think you see that, but you don't see that. The earth changed, and it's entirely likely, I'll just go out on a limb and say this, that the earth changed enough that probably the dinosaurs would not have survived regardless. Although having said that, some of them did. The non-avian dinosaurs are the ones that died. The avian dinosaurs, meaning the birds, did survive. And birds are now accepted to be the last descendants of the dinosaurs. We don't call them dinosaurs, we call them birds. But that's just because we knew about birds a long time before we knew about dinosaurs. But later we connected the dots. Oh yeah, these little things are actually dinosaurs. Imagine that. So we can't say the dinosaurs did not survive. The birds did. Well, they had feathers, they were small, they ate different food, less of it than the dinosaurs did, and the large reptiles. So they were well positioned to survive, a downturn in the ecosystem after that impactor hit, Chicxulub impactor 65 million years ago. But things changed anyway, even without that meteor strike. Things were going to change, and that's because plants had been removing CO2 from the atmosphere and burying it underground. And in other places, there was erosion, also removes CO2 to some extent. But the planet was changing. Even when the dinosaurs were at their zenith and dominated the Earth, the planet was already changing. It was becoming cooler, and as a consequence of becoming cooler, it was becoming drier. So about 4.5 million years ago, our ancestors, bipedal apes, hominids, okay, appeared on the scene. And, that just would have been another species, right? Primates are knuckle walkers, right? They walk on two legs once in a while, but mostly on four legs. But we call them knuckle walkers because their hands are huge and curved. They don't have paws like a dog or a cat. Or they have these great big huge hands and curved fingers, because what the primates did, other than like the highland gorillas, what the primates did was they brachiated, they climbed, and they would swing from tree to tree using their great big huge fingers to hook over branches as they brachiated. They basically swing through the trees. And you've seen pictures of monkeys doing this. Well, that's kind of what our predecessors did before we became upright walking apes. All right. We are descended from the apes. We're not descended from the monkeys. Monkeys have tails. Apes do not. Humans do not have tails. We are primates. Okay. But we are upright walking primates, and we are the only ones. The hominid line are the only line that did that. Now, we were in the forest along with everybody else because it was all forest at one time. At the time when the Earth changed, most recently, it has changed many times in the past for various reasons. Volcanoes and other volcanic, sometimes very large volcanic events. The Earth has gone through shifts. And it was changing this time. You can wonder why. It doesn't really matter, because it did. What it did was it cooled. The planet cooled about 4 million years ago. Humans, hominids, they weren't humans yet, but hominids, our predecessors, our direct predecessors, were on the land walking around on two legs, probably in the forests. They're walking on the ground. The other apes and the monkeys were brachiating through the trees, and our direct predecessors were walking on the ground. So it's another niche, right? There's the tree niche, and then there's the ground niche. Almost certainly, we were hunters. Almost certainly. Lots of hunters can climb trees. Jaguars and other cats are particularly good at that. But even those predators generally hunt in the undergrowth, right? They'll pad around with their stripes and their spots covering for them, giving them camouflage as they walk through the dappled light. But they're down, skulking through the brush, and they pounce on their prey. And we were almost certainly ambush predators of a kind. We were walking on the ground, our hands were free, and so just like hunting cats, we could grapple with prey, we could kill it. So that was our approach. We were already meat eaters, is my guess. We were already predatory at that point. So 4.5 million years ago, that was us. And our predecessors were small. They were like 3.5 feet tall, lightly boned, no bigger than our modern children, like 5-year-old children. But whatever they were doing, it worked for them. Then, with those people, early hominids on the scene, the planet changed. And what the planet did was it got cold. It got cold and it got dry. You need to get in your head this concept that cold leads to dry. Now, you probably have a concept that cold leads to snow. That's not correct. It may snow when it's cold. That does happen. But cold does not lead to snow. Cold air cannot hold moisture. Basic physics. Okay? Cold air is dry. Cold air cannot hold moisture. Warm air can hold moisture. Moisture can evaporate from warm water, and there will be warm air above the warm water, and the moisture will come off the warm water into the warm air, and the warm air will carry that moisture away. Warm air can contain moisture. Cold air cannot. Cold air is dry. People go snow skiing and come back with their lips all cracked and chafed. You have to wear sunscreen. You have to wear lip balm when you're up in the snow. When you're out on the ice, lip balm, because your lips will dry out, your skin will dry out, your face will dry out. It's very drying because it's so cold. You cannot have moisture in cold air. So when the planet began to cool, as CO2 was stripped from the atmosphere by plants, it began to dry up. The planet began to dry up. A lot of water in the solid form, ice, was accumulating at the poles on land. So if it's on land, it's not in the basins. It's not in the ocean basins. It's not in the rivers. It's not in the lakes. If it's frozen, it's not falling on the land and running off into the rivers and hence to the sea. So things just got very dry. The air that was blowing across the continents was cold and dry, and so it couldn't precipitate water. There wasn't any. All right, it just didn't happen. So as the planet became colder and drier, the rainforests shrank. Forests in general probably shrank. All kinds of trees at that time would have needed water. And the trees that we're now familiar with in forests, like for Europeans and North Americans and Mediterranean people, so basically the basis of Western civilization, the forests we talk about lovingly and that we go to visit with our families and to get out into the woods, those forests are deciduous forests, right? They're dry land forests. Pine trees are very conserving of water. They just get a trickle of water from the snow as it melts, and most of it runs off, but they get some of it, and they grow really well. There are some exceptions, like the Pacific Coast redwoods that grow in the fog, so there's fog. But by and large, the forests that we know are these dry land forests. So most of us, since we're not from South Asia, or not from Africa, we're not from Central America, South America, most of us, northern white people, only know a certain type of forest. It's a dry land forest. It grows relatively well in the cold and the dry. So when the earth began to cool and dry, the tropical forests shrank back to the only place where they could really get tropical conditions anymore, which is right at the equator, in the rain bands, where the water's still really warm, there's no ice, there can be evaporation, it can fall quickly onto the land as rain, and so they managed to continue living in these places. But elsewhere, where the ice was closer to the poles, which means mostly North America, Northern Europe, all of Europe really, and all of Asia pretty much, um, would be either under ice or in very dry conditions. So this was the environment into which humans stepped. We stepped into that environment, and literally we were walking on two legs, so we could do that. As the planet began to cool and dry, about 4 million years ago, we were probably already carnivores. We were on the forest floor on our two legs. That's how we are. That's how we do it. We did it then, we do it now. It worked, right? We were on the forest floor, walking on our two legs. We were not break eating in the trees like chimps. We were walking on two legs on the forest floor. We were almost certainly predators. Maybe we were opportunistic predators, but there's not a lot of fruit down there. The fruit is not down below. There's a lot of leaves, but we were walking, and we were walking for a reason. We were probably chasing things already, other animals living in the forest. And so when the dryness came and the forest began to shrink, two things happened. There was a new biome, a new place to live, and there was less of the old place to live. So what typically happens evolutionarily is that species that are maybe a little bit pre-adapted for the new habitat will start to venture into it. They're adapted for it. I mean, they're walking on two legs, so they can deal with the savanna. A monkey, brachiating through the trees, is going to look at all that grassland and the dry conditions and say, yeah, that's not for me. And it isn't. They don't walk very well, so they can't deal with the grass, and there's no way to swing through the trees because the trees are gone. So when the day came that it wasn't the day, of course, it was the century, the eon. When the time came that savanna became prevalent and began to dominate the environment, we were pre-positioned to just whack out onto it and just take advantage of it. As it happened, there were lots of other animals that did the same thing. We associate the grasslands and savannas and these open prairies with large herds, right? You see these large herds in North America, not anymore, but you did when the white people first showed up before they killed them all. We had huge herds in North America. We had huge herds in Africa. We'll still do, obviously. There were also gigantic herds of horses and camels and things roaming Eurasia, so Europe, and it's nearby Asian portions. People still herd animals in these places. Not so much Europe anymore, but in Eurasia and the Russian steppes, they still herd animals there. So we walked out of the forest onto the savanna and found meat. We found meat. And that probably was why we did it. We were already hunters and carnivores, and the jungles were getting smaller, and maybe the animal species were getting smaller because that happens. It's called island dwarfism. So animals, as the habitat begins to shrink, the great big animals can't survive anymore, and the little pygmy versions survive pretty well. So the animals we were hunting probably became smaller and less numerous, and so we just walked out onto the prairie and took advantage of it. So one way to look at that is that humans are a disturbance species. We took advantage of a disturbance. It was a planetary disturbance, and we took advantage of it. We were in the jungle. That's pretty much all there was. We were probably on the ground in the jungle, maybe even on the edges. Maybe we would venture into the open areas to hunt. But later on, when the prairie showed up and all these gigantic herds, we were there, right? We were there. And we hunted those big animals, and we learned how to hunt them cooperatively. So if we were not cooperative at the beginning of our evolutionary trajectory, we became cooperative, and we had a great food source. So long as we were prepared to hunt cooperatively, we had a great food supply. It's probably about that time that our brains began to grow evolutionarily. We have a very large brain. It takes huge amounts of calories to do that. You can't really do that as an herbivore. You can do something like that, but our brain is really expensive. It's expensive to grow. It's hard to birth a baby with a brain that big. There are risks involved. Proper brain development can take years, maybe a decade, and the children are not capable during that time. So there's an expense there that they can't help. Plus, they have to be cared for by parents who have to dote on them, and they can't go do other things like hunt or gather food. And it's just, the way we do things is really expensive and very risky. The only reason we can pull this off is because we had a massive food supply, huge food supply. So the males could get huge, buffed, muscular. They could go out in their groups, hunt these big animals, big, fast, angry, violent animals, kill them, bring them back, and everyone would eat, and they eat really well. And it worked great. But it happened the way it did because the earth became disturbed. The trajectory that the earth had been on, warm, wet, rainforest, crocodiles at the poles, that whole thing became broken. And we went into an ice age and a series of glaciations. So fast forward where we are now. Now we're heating the planet. How are we doing that? We're digging up the stored carbon in the ground that the plants put there, and we're burning it and releasing it back into the atmosphere. So we're reversing a process that was actually part of our evolution. That the cooling and drying of the planet, which required the removal of CO2 from the atmosphere by plants, we're reversing that and we're putting it back in the atmosphere. So when I started this, I was saying, I was saying, okay, now we have to start thinking about where all this is headed, right? Because it's clear now to me that we're not going to stop it. I'm not sure we ever could, by the way, but it's clear now that we don't want to. All right, so between the fact that we probably can't and the fact that we don't want to, it's not going to happen. I guess it could happen on accident, right? Whether we just had a pandemic, but maybe we have a series of pandemics that implodes the economy and kills a bunch of people and forces people to stop flying and driving and changes how we do things, and we have to cut back on our carbon consumption just because we just got whacked, right? Or maybe a meteor could come and whack the dinosaurs. Maybe we get one to whack us. Some random thing, possibly, right? But short of a random thing, or like a random pandemic that lasts for 20, 30 years, there's nothing to stop us at this point. We don't know how to stop. And also, we don't want to stop. So we're not going to stop. So if that's the case, then we're going to keep pulling these carbon resources out of the ground, burning them to get the magic out, and lofting the combustion results back into the atmosphere. That's what's going to happen. So given that scenario, and given that that's how the planet used to be, where are we headed? Well, there's really not much of a question where we're headed. We're headed back to a hothouse Earth, just like it was, 20, 30, 40 million years ago. Every year the load of carbon dioxide in the atmosphere increases. It's not going down. It's not even plateauing. It's going up. And the rate it's going up is going up. So it's accelerating. There's no sign of this stopping. No sign of any kind of this stopping. We're already at 420 parts per million of just carbon dioxide. If you include the other things that act like carbon dioxide, like methane and nitrous oxides, that that we produce. Okay, they're not measured as carbon dioxide, but they're in the atmosphere because of us, and they act like carbon dioxide and they're greenhouse gases. If you include those and add them to carbon dioxide, you get a carbon dioxide equivalent of 500 parts per million. So we're already way out there with all the stuff that we've put in the atmosphere from burning fossil fuels. What was the CO2 concentration of the atmosphere back in the time of the dinosaurs? I really don't know. I'm not sure we even have records for that. A lot of our CO2 records actually come from ice that has trapped little tiny bubbles, microscopic bubbles of air in them. And so when we're doing ice cores, like at Antarctica or on Greenland, we do ice cores, we bring the ice up. We can see the little bubbles in there. And so we slice through a piece of ice, we put it in a vacuum chamber, pull up, let it melt, pull all the air out of the bubbles, and we analyze the air. We can analyze the air with sufficient accuracy to determine what its carbon load was when that bubble was captured in the ice. But that's using ice. Okay, so guess what? That methodology cannot give you an answer at any time on the planet when there was no ice. Maybe there's something else we could sample, right? Like ocean sediments or something like that. Maybe there's isotopic analysis we could do. I know they do that with oxygen. Maybe they can do something. I don't know. But we don't really know. I don't know that we even know what was the concentration of CO2 in the atmosphere back when this was a hothouse Earth. But I can tell you with some degree of confidence that we're going there. We're going there. We may already be there. There's a decent possibility that right now we've already met the requirement of reverting this planet back to a hothouse. So let's talk about that for a moment. If that's our future, let's talk about that for a moment. So what does that mean? Well, that means that the planet, as the planet warms, as the waters warm, as the soils warm, as the atmosphere warms, it can hold more moisture again. The dryness of the planet that was conducive to the huge herds and the savannas and us, the dryness of the planet will be reverted. It'll become potentially more wet. On the East Coast, they're kind of seeing that right now. There's a huge plume of warm, hot air coming from the Gulf Stream, which is abnormally warm. And it's interacting with the cold air coming down from the north. It's creating this huge bomb cyclone over there. At least it was doing it last week. So, this is now our reality, is large masses of warm, wet air being able to collide with other air masses and release a lot of precipitation, right? Snow in the winter, but then rain in the summer, and we've certainly been seeing that. We've also been seeing an increase in hurricanes. Hurricanes are basically water hoses, like fire hoses. What they do is they scoop up huge amounts, billions of tons, I suppose, of moisture off the warm ocean. Then they take it inland and they dump it. Remember, there was that year when there was some hurricane remnant that stalled over Houston and dropped 52 inches of rain and just about destroyed those people, right? That's what I'm talking about. These things are like fire hoses. So, there's certainly evidence now that we're going to have wetter storms, possibly more storms, bigger storms, and more moisture coming ashore. So the trajectory of that is that this manages over time to reverse the process of the Earth being dry and cold in relative terms, and now becoming warm and wet. And they call that hothouse Earth. Now, another way to think of hothouse Earth, and in the intermediate phase, which we'll certainly go through first, is that the process of heating the Earth actually outstrips the Earth's capacity to react. The normal reaction to heating an area and putting more moisture into it is that you get more plant growth. But plants grow really slow, and the migration of tropical species into temperate and northern areas is going to be like glaciers. It's going to be like watching paint dry. It's going to take forever. We might actually get involved in that at some point. We may actually start planting these plant species that grow really well in wet, warm areas, just to have something that can survive and hold the soil together, and block the winds when the hurricanes come, but also to have the food, right? Bananas, papayas, whatever else, right? Whatever can grow, we should probably be growing it if the habitat's going to change. But if we don't deliberately do that, then the first thing that's going to happen is not a tropical rainforest sprouting up in your front yard. The first thing that's going to happen is it's just going to get hot. It's going to get hot without the tropical plants. It's just going to get freaking hot. So one way to use the term hothouse Earth is just that it gets freaking hot, which it can do quickly. It can do any day it wants to. Right now, they're having really hot days in the far north. Well, certainly in their summer. And right now, it's in the far south because this is our winter, their summer. Really hot days, comparatively speaking, in these remote polar regions, right? People complain about it. The ice is melting, the roads are melting. Well, the roads are built on permafrost. We didn't even bother worrying about stabilizing the roads, and now the roads are melting. The permafrost is melting, the roads are turning into bogs. It's a big problem for them. They're having huge fires up in Siberia, fires that burn all the time. They never stop burning. They go to sleep for a month or two in the winter, and then come spring, they're right back burning, just exactly where they were. They never stopped, they never went away. This is really unusual for them. They don't know what to do about this. But, for us, it's signs of the planet heating. And so, we'll get hothouse Earth, meaning it's just going to be freaking hot a long time before we get the result, which is the plants change and we get rainforests. Okay, so that's fine. Now, There's obviously a downside to record-breaking heat for us. We cool ourselves with electricity or we die. So are we going to be able to adapt? I don't know. We're going to have to adapt at the same time that a lot of our electricity infrastructure, which is reliant on fossil fuels, is going to have to go away. So what is it? Nuclear plants? Probably lots and lots of nuclear power plants, whatever the problems are with those, and there's plenty. Maybe I'll make a video about that in the future. But we'll have to deal with the heat. But then, let's say we do deal with the heat after 1,000 years dealing with the heat. We end up being on a green planet. So that should be okay, right? Green planet. You have the blue of the water and the green of the land. Everything's green. It's all tropical. There's no ice anywhere. There's people living comfortably in Antarctica because all the ice is gone. It's maybe a little cold in the winter, but you can still live there year round. And so at some point in the future, 500 years, 1,000 years, that's the scenario. But if the balance of the Earth is green and it's forested and jaguars and tapirs and capybara and all that kind of stuff, where are we? Because that's not our habitat. It's not our habitat. That's not where we evolved. We started there. But most of our evolution as hominids, but also even as modern humans, was on the savannah. We were hunters, and we would run after the herds, and the herds were huge, and you could see them for miles, and you knew exactly what you were doing. And that's how we got to where we are. That's how we got to where we are. We eventually settled down, and domesticated animals and domesticated plants and modern agriculture, as we know it today, got its genesis. But that's not how we evolved. We evolved on the savannas chasing animals. So what are we going to do when there's no savanna? It's worth pointing out that if there's no temperate prairie for the gigantic herds to graze on, there's also no open land for you to plant your corn, wheat, barley, and all these soybeans, all this other stuff. If the Midwest turns into some sort of a rainforest, you're not going to have row crops. Now, maybe you spend all your time cutting down trees and pulling up the stumps and trying to keep your land clear, but who can say that you can even fight that? We found these places. We found the prairies. The bison were out there grazing. We found that open land, and then we tilled it, killed all the bison, killed the Indians, tilled the land, and started planting our grains, which were perfectly suited for that habitat. We found it that way. We didn't make it. We found it that way. We found it in the Russian steppes. We found it in Central Europe. We found it in parts of Asia. We found open ground. And we planted it. We grew crops, in particular grains. Well, if this reverts back to being a greenhouse Earth, you're not going to do that. You're not going to find that ground. Now, maybe you can fight for it. Maybe you can expend a certain amount of your effort constantly fighting for it. But even if you cut all the trees down and keep cutting them down and keep finding ways to get rid of them, can you have cereal crops when it rains all the time? The answer is no. They flood. They float away. The seed kernels actually float away. They plant rice and rice paddies. They actually stick them in the ground. They go out there with an armful of rice and they just stick it in the mud like this, okay? There are certain things you can raise in these wet environments, but it's going to be hard. It's going to be really difficult. And as the Midwestern farmers will tell you, one bad hailstorm, one bad rainstorm, and your crop is gone. If you don't harvest it before that hits you, you can't get it up. You can't get it in the silos. And you can't put it in the silos wet because it'll mold. There's just a lot of problems trying to raise grains in a wet, hot environment. And it's conceivable, in fact, that it won't happen. So we may grow other things, legumes, beans, peas. They may grow okay. We may do more things in greenhouses. We may be a very technically advanced species at that point. We may have all of our agriculture may be grown underground or in gigantic arcologies with artificial light. Who knows? But it's going to be different. It's not going to be like it is now. And one of the things that I will contend is that if we're not able to do things the way we do it now, then we can't be 8 billion people. We weren't 8 billion hominids when we stepped out of the disappearing rainforests, deciduous forests, onto the savanna. There wasn't 8 billion people of us doing that. There was maybe a couple 100,000 humans, maybe 1 million humans on the entire planet. Probably not even a couple 100,000. We are a large animal, and we can't be too abundant in these very limited habitat. So we were not abundant. Now we are 8 billion, but that's because of grains. Can you do 8 billion people with papayas and mangoes and tropical fruits and nuts? I don't know. Can we continue to grow grains in an environment where it rains all the time? Don't know about that. Don't know. So we may find ourselves on a planet that if it is not hostile to us, which parts of it will be, sea level rise is going to be very hostile, okay? There's no bargaining with that particular devil. It's going to be bad. So if you set aside the actual acts of hostility for a moment, will it be hospitable to us? And it might not. The planet as we are now directing it will look completely different to our way of doing business and may not be hospitable at all. And this is where you start. That's if you set aside even the initial change, which is simply heat. We would have to survive 200 or 300 years of just agonizing heat before we could even get to a place where we would have a green planet and forests everywhere, because that takes hundreds, thousands of years. So between the initial hothouse Earth, where it's just hot, versus the later hothouse Earth, where it's wet and green, but it's still hot and there's no ice anywhere and there's no open land left anywhere, between those two events, we may find that this world simply won't support us. There are people who talk about near-term human extinction. I think they're wrong. I don't think there's a near-term human extinction possible. I don't think you take 8 billion of anything and make it go extinct. I just don't see how that happens. I guess we could do it with warfare. We could mechanized, in a mechanized way, annihilate each other, and then, the last survivors die of the heat. I guess that's possible, but it doesn't seem very likely. And, but even if you don't allow for near-term human extinction, we can't eliminate the possibility of long-term human extinction. And, it may be something more subtle than even just we disappear from the planet. We may regress. We may regress. We may start to recognize that, genetically, that the place we have to live is now a forest. And, we may give up walking on two legs. We may end up living in trees. We may go back to being brachiators and living in trees and more like squirrels, right? Climbing up and down trees. We may be modern humans in every respect, have language, storytelling, all that stuff. But now we're living in trees because that's the habitat. That's where the food is. That's where the safety is. That's where you go. So who knows? That it's not guaranteed that we can go forward the way we are. It's not guaranteed that this planet will be available for us to do that. It may become a different planet. And if it becomes a different planet, meaning a planet that none of us would recognize, not even from space, okay? You can look at a picture of it from space. Where is that place? That's a beautiful green planet. Yeah, that's Earth. That's Earth 1,000 years from now. Maybe we're not there. Maybe we're not there. We changed the planet and we changed it out from under us. The dinosaurs, the planet got changed out from under them. That wasn't their fault, right? That was a meteor strike. They didn't do anything to cause that to happen. Well, we're doing this. We are doing this. If you don't believe that, well, then you've got my sympathies. Okay, maybe you need to educate yourself. I don't even care. I don't care what you do. We're changing the planet. All right, the planet is changing, and it could change out from under us in a way that we can't cope with. It's a possibility. Not in the near term, I don't think. Well, the heat strikes are going to be bad. The heat will make some parts of this planet uninhabitable. The heat by itself. And the other places that are trying to raise food for the masses, and now, of course, they're refugee masses because they're having to abandon their prior habitat. The food places growing food may not be able to do it quite as well because of the heat, or actually, maybe ironically enough, because of the rain. Okay, hurricane can come through and just destroy an entire crop for that season. 2 or 3, 4 states could just, of the United States anyway. And heat waves in Europe impact, and heat waves in Russia impact their ability to grow food. There may be new forms of disease, new forms of pests like locusts that just become to dominate because they find good conditions. Who knows? It's impossible to say. But what is possible to say, and what should be said, is it's going to change. Everything you thought you knew is not going to go forward. It can't. The planet has changed. You can't do those things anymore. You can have the internet, you can have your iPhone, but you can't grow wheat. You can have your iPhone 57, but you can't grow wheat anymore in the Midwest. Why? I don't know why. Too many hailstorms, too many tornadoes, too much rain at the wrong time of year, too much rain early in the year, too much rain late in the year, not enough rain when it's supposed to rain. Who knows why? It's changing. It could change in all kinds of ways, countless ways, scores of ways it can change. None of which are like this. None of which are what we're accustomed to. The hothouse Earth is absolutely coming. And for a while, maybe 100 years, it'll be heat. Just freaking hot all the time until there's no ice left on this planet. Hot. And then after that, it becomes a jungle. And that's also a set of problems all by itself. And, so here it comes. Here it comes. We could have changed that, but we couldn't. We could have. I mean, technically we could have, but now we can't. So we're not going to. And so when I say I have no hope, that's what I have no hope, that we're not going to be able to change this. What comes after? Well, that was my rundown on the options, the likely things that will happen. And I don't see those future Earths being particularly suitable for humans at all. And certainly not the way we're doing things now.